math friends. We are on page 131 of the CC3 book. You can also follow along on lesson 323 in your ebook if you'd like. So today we're going to talk about how can I use my equation solving skills. And we are going to go back to taking a look at those tile patterns that we looked at earlier in the year. So solving equations to solve problems. In the last two lessons, you have practiced solving equations. In this lesson, you will apply your equation solving skills to the patterns you found at the beginning of the chapter. As you solve these problems, keep these questions in mind. How can you simplify? Is there more than one way to solve? Can you get x alone? And how can you check your solution? All right, so number 89. In lesson 313, we investigated the big C's pattern of tiles shown at right. The rule you found for the pattern was y equals 6x plus 3, where x represented the figure number and y represented the number of tiles. Let's talk about that just for a moment. Let's talk about a table where x is the figure number and y is the total number of tiles. Okay, so figure number 1 has 9 tiles, figure number 2 has 15, figure number 3 has 21. And they're telling us that this equation that represents this was y equals 6x plus 3. But let's take a look again at how we figured that out, because when we get to chapter 4, we're going to be doing a lot of work with a lot of different patterns that represent linear growth, and it's good to understand what's going on. Okay, so figure number 1 was 9, so I'm going to put the 9 right down here. Excuse me. I'm going to change color, actually. Let's go to blue. Figure number 2 is 15. Figure number 3 was 21. The rest of these were blank, but what we discovered was that as we move from one to the next with the total tiles, that it was growing by 6. It was adding 6 every time. And then we could go forward and backward, and we could fill in the rest of these kind of sequential figure numbers and figure out how many tiles they had. So 21 plus 6 was 27. 27 plus 6 is 33. And 33 plus 6 was 39. What we can also do then is move backwards. If we're adding 6 as we're moving forwards, we can subtract 6. So what we would have here is 3. Now that's important. This is important because remember when we graph that this is the y-intercept. This is this part right here of that, okay? So that's the y-intercept. The plus 6 was the growth. It's attached to the variable by multiplication, and then plus 3 was the y-intercept. Okay, so then now that we have this figure, figures 1, 2, 3 figured out, figure 0. Penelope wants to know how many will be in figure 50. How can you determine this? Well, it would be sort of tricky to keep, we could continue our table, right? And we could continue our table and we could think in terms of, well, we could just go all the way up to 50 and keep adding 6. Would that work? Absolutely. But now that we know that we have the equation, let's just use the equation. So how would that look? Okay, so how that would look is this. Y equals 6x plus 3. And what we're going to do is we're going to substitute in, since x is the figure number, we're going to substitute the 50 in for the x. Y equals 6 times 50 plus 3, and we're going to solve that. But actually, I'm going to move to the next page because I'm running out of room. Hold on just a moment. Okay, more space. So here we have our rule again, and I substituted in figure number 50. So now all we simply have to do to figure out how many tiles are in figure 50 is do the multiplication. So y equals 6 times 50 is 300 plus 3. Y equals 303. There are 303 tiles in figure 50. Okay. Now, let's take a look at kind of reversing the process. Let's say we have a tile, tiles of 45, and we want to know what figure number that is. So now we know 45, that's the total tiles, but we want to figure out the figure number, 6x plus 3. Well, now it's a different sort of solving an equation, but it's certainly doable, okay? Now we're thinking about all of our skills for solving equations and how we go about doing that. Okay, minus 3 to both sides. This is our original equation. We're going to minus 3. Okay, now over here I have 42 equals 6x, because of course this was a zero pair. We did that to both sides. Okay, now our last step is to do what? Divide by 6, right? Because that's the coefficient. It makes this giant 1 here. X equals 7. Okay, so what does this mean in terms of our question? Let's look at our question again. Question said, Lou knows that there's 45 tiles in a figure. He wants to know what figure number that is, or in a tile pattern. So now that he's plugged in his 45 up here, he can actually figure out this is figure number 7, has 45 tiles. Pretty cool. Exclamation point. All right, one more thing I wanted to take a look at, and it's a way to see growth. And this is also something that you're going to be taking a look at when you move into chapter 4. And let's take a look at just the big C tile pattern again and talk about the growth. Okay, so we knew that we had 9 tiles here in figure 1. We had 15 here in figure 2. We know we had 21. These were growing by 6 every time. They were adding 6. So we knew that was part of our rule, right? But where can we see the 6? That's the question, okay? So I'm actually going to start here in this figure number 1, and I'm going to look at what's happening from figure 1 to figure 2. And what I see happening is that there's an extra piece here and here, okay? And also these extra ends are being added on. Do you see that's the growth? And notice that that's 1, 2, 3, 4, 5, 6, okay? Let's take a look at the growth then from 2 to 3. And again, from 15 to 21, I've got 2 here, okay? I've got the 2 here that are kind of pushing it and making it higher. And I also have the 2 here, and that represents our 1, 2, 3, 4, 5, 6 of growth. And so then working backwards, what I would do is I would take out these 2, well, probably not those 2. Let me try to do something different. I'm definitely going to take out these 2 and these 2, but I have to take out 2 more, and it's probably going to be this one and this one, because I think figure 0, our y-intercept, I'm trying to get my drawing here, is going to be just, if I can even draw it in, 3, those 3 right there, okay? So this would be 0, our y-intercept. Anyway, okay, I just wanted to talk to you a little bit about that because it's interesting to see the growth and be able to highlight and visualize it. So on to the next lesson.